Hello everyone, this is Sindhu. I am from Sri Venkateshwara College of Engineering. My topic has asymptotic notations. Index is what is algorithm, definition of the asymptotic notations, and types of asymptotic notations, and explanations of about that. What is algorithm? A set of finite rules or instructions to be followed in calculations or other problem solving operations, or a procedure for solving a mathematical problems in a finite number of steps that frequently involves recursive operations. Therefore, algorithm refers to a sequence of finite steps to solve a particular problem. What is asymptotic notations? Asymptotic notations are used to represent the complexity of algorithm for asymptotic analysis. These notations are mathematical tools to represent the complexities. There, there are three notations that are commonly used. Asymptotic notations is a way of comparing functions that ignores constant factors and small input sizes. Three notations are used to calculate the running time complexity of an algorithm. First one is big O notations. Big O is the formal method of expressing the upper bound of an algorithm's running time. Second one is omega notations. Third one is theta notations. Different types of asymptotic notations are: first one is big O notation, second omega notation, third one is theta notations. What is big O notations? Big O notation. It is defined as follows: bound and lower bound on an algorithm is the least amount of time required, the most efficient way possible. In other words, best case. Just like big O notation provides an asymptotic upper bound. Omega notations provide asymptotic lower bound. Let f of n defines running time and of an algorithm. F of n is said to be omega of g of n if there exists possible constant c and n not such that O lesser than equals to c g of n lesser than equals to f of n for all n greater than equals to n naught. N equals to use it to given lower bound on a function if a function is omega of n square, it is automatically omega of n as well. It is used to graphical example of big O omega. Big theta. Big theta. It is defined as tightest bound, and tightest bound is the best of all the worst case time that the algorithm can take. Let f of n defines a running time of an algorithm. F of n is said to be theta of g of n if f of n is big O g of n and f of n is omega of g of n. The equation simply means there exist possible constants c1 and c2 such that f of n is sandwiched between s2 c2 g of n and c1 g of n. The bounding of functions from above and below is represented by theta notations. The exact asymptotic behavior is done by these theta notations. And big O big O notation. Big O is the normal method of expressing the upper bound of an algorithm running time. It is the measure of our longest amount of time. The function f of n equals to big O g of n. Read as f of n is big O of g of n if and only if exists possible constant c and C is defined as upper bound, and upper bound on algorithm is the most amount of time required. The worst case performance. Big O notation is used to describe asymptotic upper bound mathematically. If f of n describes the running time of f of n algorithm, f of n is O of g of n. If there exists possible constant c and n not such that 0 lesser than equals to f of n lesser than equals to c of g of n for all n greater than equals to n naught. Hence, function g of n, an upper bound for function f of n as g of n grows faster than f of n. For example, 3n plus 2 equals to big O of n as 3n plus 2 lesser than equals to 4n for all n greater than equals to 2. Thank you for watching my video. Please like and subscribe.